Hi, everyone. This is a project for the subject of hydrology. The title for this project is Hydrological Data of Rainfall, Evaporation, and Infiltration Across Residential Locations. This is a member in Group 4, which is Thumilena El Ravi, Muhammad Yusri bin Mustafa, Muhammad Fadil bin Azman, Farhan Shami bin Adnan, and Nuradila binti Rahim.
Our main focus areas are rainfall, evaporation, and infiltration. These are key components in understanding hydrological responses to climate and land characteristics. This project involved a data collection period from 22 to 28th of May 2025. The objective was to monitor how different locations respond to the same dry weather conditions. The data was collected manually using rain gauges, evaporation data tools, and infiltration testing methods. We selected 5 locations around Batu Pahat, including Jalan Yai Siti, Sri Gading, Apartment Taman University, Jalan University 15 and 16 within Taman University. These locations were chosen due to differences in land cover.
The equipment needed to make a rain gauge is a 1.5-liter bottle, measuring tape, ruler, paper, pen, and scissor. This is tutorial to make a rain gauge. Firstly, cut the top of the bottle evenly. The cut part was reversed by inserting the bottle nozzle inside and attaching it using black tape. At the same time, mark a 10 mm scale on the paper that has been folded lengthwise, and final part is attach it to the ruler to attach to the bottle.
For rainfall, during the observation period at 2 p.m. from 22nd to 28th May 2025, all 5 stations recorded a total rainfall of 0 millimeters. This indicates that no rainfall occurred at any of the locations throughout the study period. Evaporation data was recorded from 22nd to 28th May 2025 for all 5 stations. This is evaporation data at Apartment Taman University, Parrot Raja. The highest temperature was 28.4 degrees Celsius on 24th May, which matched the highest evaporation rate of 4.25 millimeters. Average EZO for the week was 3.99 millimeters. Low humidity between 54% and 65%, along with wind speeds of 1.3 to 1.8 meters per second, supported higher evaporation. The N/D ratio also indicated clear skies, which increased sunlight exposure and evaporation. To find N value, use formula N equals D multiplied by 1 mass cloud coverage and divided by 100. Overall, dry air, sunlight, and wind were the key factors contributing to consistent and high evaporation at this site.
Next, evaporation data at number 15, Jalan University 16, Taman University, Parrot Raja. We used the Penman method to calculate evaporation. Using this data, we calculated daily evaporation values. The results showed E range between 3.05 millimeters and 3.9 millimeters, with an average of 3.51 millimeters per day. The highest evaporation was on 26th of May, due to high temperature and moderate humidity.
The evaporation study was done at number 5, Jalan University 16, Taman University. The highest temperature was 28 degrees Celsius on the 25th May. The values ranged from 3.6 millimeters to 4.3 millimeters, with an highest evaporation rate EZO of 3.94 millimeters. The highest evaporation was on 24th May, 4.3 millimeters due to high temperature and low humidity. The cloud coverage ranged between 65 to 71%.
Evaporation data was collected at number 35, Jalan University 15, Taman University. Using these inputs, we calculated daily evaporation values, known as EO. The values range between 1.63 millimeters to 2.44 millimeters, with an average of 1.97 millimeters per day. The highest evaporation occurred on 23rd of May, likely due to high temperature and moderate humidity.
Last evaporation data at a residence on Jalan Yai Siti, Sri Gading, Batu Pahat. All data was taken from online weather sources based on the exact location. Sunshine duration was calculated using the cloud coverage, and total evaporation EO was found by combining the 4 Penman components E1, E2, E3, and E4. The results showed daily evaporation values between 3.3 millimeters and 3.77 millimeters, with an average of 3.59 millimeters per day. The highest evaporation occurred on 27th of May, due to higher temperature and moderate humidity. Since there was no rainfall during the week, the evaporation values represent actual water loss from the land surface.
This is a tutorial on how to make an infiltration ring using recycled cans. Start with a clean, empty can. Make sure it is free of labels and sharp edges. First, measure 2 centimeters from the outside of the can from the bottom of the can and mark that line. After that, measure 5 centimeters from the inside from the top of the can and mark that line. Infiltration rate. Go to an open area for the test. Push the can about 2 centimeters deep into the ground using a hammer. Make sure it is stable and upright. Then slowly pour water into the can. Once the water is poured, start timing using a stopwatch and observe how quickly the water level drops.
For the infiltration rate, we all decided to do infiltration on 26 May 2025. From the experiment, all stations took 4 laps for 1.5 liters of water to absorb into the soil.
For the conclusion, the rainfall, evaporation, and infiltration data from the 5 Batupahat stations show that even under the same dry weather conditions, different sites reacted differently due to land characteristics. Infiltration was higher in well-drained soils and lower in compact or less permeable soils. This proves that local soil and land cover strongly affect water movement and should be considered in water management planning. Thank you very much for your attention.